Resolving hardware compatibility issues. In this nugget, we put on our troubleshooting caps and begin to learn how to maintain some of the hardware that I've made you familiar with over the course of the previous dozen or so nuggets. Specifically, the exam objective we're concerned with here is that of assessing hardware compatibility. We'll look at motherboards, RAM, peripherals, interfaces, and then network. Let's get to work. Before we go any further in terms of troubleshooting compatibility with hardware and troubleshooting hardware in general, I think it's instructive for us to take a look at the troubleshooting model that CompTIA gives us. Now, mastery of this model is not at all necessary for this strata exam. However, if you do plan to certify with the A+ computer repair technician and or the Network Plus network technician credentials, then you'll absolutely need to understand this. Now, most original equipment manufacturers or OEMs like Microsoft, Apple, Cisco publish their own troubleshooting models that their employees use on their support desks and they recommend for use by other people. Now, I think it's a good idea to pay close attention to the published computer hardware and software troubleshooting models that folks like Microsoft, Dell, and Apple put out, because when you think about it, all of those companies produce a lot of hardware that's used all over the world by millions of people. Now, I think it's pretty nice of them to share their best practices based on trial, error, etc., such that we in the public can make use of them as well. Now, CompTIA's troubleshooting model is in a sense an amalgamation of several other related troubleshooting models that are published by individual vendors. After all, remember that CompTIA is a nonprofit organization that consists of technology vendors, among other parties. The 6-step process is as follows. When we're troubleshooting computer hardware or software, step 1 is to identify the problem. As a PC repair tech, this often requires interviewing the affected person or people to figure out what's changed since the problem has cropped up. If the problem exists in network equipment, then the people that you might want to question would be the vendors if they're providing support for that hardware, or other folks in your IT department. We want to reproduce the problem whenever possible. I know there's an old adage that says if you have, for instance, car trouble that's persistent, as soon as you bring your vehicle into the auto repair shop and you have a technician there, suddenly the problem doesn't show itself. That can be awfully frustrating. The same thing can happen with computer hardware and software troubleshooting. So generally speaking, we're talking about a deductive process. That is, we're starting with a lot of information and we're using various techniques to whittle down what we feel is the root cause problem behind your support issue. Once you've identified the problem based on symptoms, you want to establish a probable cause. This again deals with that notion of root cause analysis. Think of it this way. You may be able to, in the short term, figure out what's causing a server to freeze. Maybe you just restart the computer and then the server stays online for several days until it spontaneously, so to speak, freezes again. Then you restart it ad infinitum. You're not really fixing any problems here. You're identifying the problem, namely the server is freezing and denying service to all of your network's users. But this quick fix really is just temporarily relieving symptoms. It's not fixing the underlying root cause. Step 2 in the CompTIA troubleshooting model means that we have to establish a probable cause such that if we resolve that, then any of the related symptoms that we've been treating, so to speak, will go away. We want to test our theory by making one change at a time to the system configuration. A common mistake that newcomers to IT support make when they're troubleshooting computer hardware or software is that they'll use the blunderbuss approach. That's what I call it anyway. You remember in cartoons especially, the blunderbuss was a rifle that had a really wide mouth on the end of the barrel, and the idea was it projected a tremendous amount of material out the end. Similarly, if you just perform a whole bunch of changes at once on a PC, restart, and you find that the problem's been resolved and it's gone, how do you know which of those many steps it was that actually resolved the problem? This is going to get you into big trouble when you get down to step 6, when we're documenting what happened. So we make changes one at a time. Make one change, test to see if the problem's fixed. Make another change, test to see if the problem's fixed. Another nice thing about making only one change at a time before testing is that we have what's called a rollback plan. It's a lot easier to just roll back the last step you performed as opposed to figuring out which of the 6, 7, or 8 steps you previously performed all in one sequence before testing. Once you determine the root cause, the next step, the fourth step in the troubleshooting model, is to enact a plan of action. How will you actually resolve the problem now that you've identified it, you've used your testing method, you've come up with a fix? It's time to actually implement that and see what happens. Step 5 is verifying full functionality. We want to repeatedly try to reproduce the problem like we did in step 1 to ensure that it's resolved, that it's not just a temporary patch or quick fix. Finally, on step 6, this is another step that IT newcomers tend to miss. Document the issue. Look at it this way. You might have just resolved a problem on a particular server, and let's say you have 10 colleagues in the IT department. If you do not document the problem, the troubleshooting steps, and the resolution in your organization's or in your department's documentation database, then let's say 3 months in the future you go on vacation, another server has the same problem. Well, you're going to be wasting your colleagues' time and providing unnecessary downtime to network users if you don't have that documented, because then when your colleague first goes to look at your company's knowledge base, in other words, your company's internal document repository of these troubleshooting solutions, there's not going to be one for this problem, so the individual is going to have to go through all these steps, taking so much more time than if you had on the outset documented the issue and the solution. You go on vacation, somebody else can consult the knowledge base, follow your steps to completely short circuit all of the steps and pretty much just go from 1 to 5 in a very small amount of time. Alrighty then, now that we have the CompTIA troubleshooting process covered, let's now look at some specific troubleshooting strategies with regard to compatibility and performance of motherboard components. A leading indicator that you have a problem with some component of your system board is that the computer locks up tightly. In other words, you get what's called a full system freeze, where either during the startup process, the machine spontaneously freezes and reboots and goes into what's called a reboot cycle, or alternatively, you could get to the point of logging into Windows or Mac OS, whatever your host operating system is, and everything's hunky-dory, and then boom, the system experiences what's called a kernel panic in the Mac OS X world, or a blue screen of death in the Windows world, and you have to restart in order to try it all over again. Specifically, let's now look at processor performance. Some things that we're looking at in terms of compatibility and performance are excess heat. Your CPU is going to be generating too much heat and putting not only itself at risk, but other motherboard components if, for instance, the technician has not adequately researched the capabilities of the underlying MOBO or motherboard. Remember, I mentioned earlier in the course that your motherboard documentation is your best friend as far as letting you know what processors can or cannot be installed on that MOBO. Making the wrong choice here is going to produce a compatibility problem that could very well generate too much heat and fry the CPU, if not the entire motherboard. Another thing that is much less likely to happen in practice, but it's still a possibility and could produce system lockups, is if you have a program running with processor affinity enabled. Now what that means is, if you have a multi-processor system that actually has more than one processor die on the motherboard, or alternatively a single processor with multiple cores, you can actually, in your host operating system, point a process or point an application to run exclusively within its own dedicated core, instead of letting the processor determine which core is running that process or processes. The idea is that you can devote more CPU resources to a specific application. Let's say a graphic designer uses Adobe Photoshop a lot. You as a systems administrator may configure that software to have an affinity toward a particular core in that processor to give it dedicated processing speed, like we said before. That can cause instability sometimes in a system and is a place where you want to look when we're troubleshooting motherboard and CPU issues. Finally, we can look at the software itself to determine if there's an incompatibility between it and the underlying operating system and ultimately the CPU on the motherboard. You can figure out if a software is at issue by looking for what's called a pegged CPU condition. In Microsoft Windows, for instance, we have this application called Task Manager, and you see here I'm on the Processes tab that shows all of our running programs. And note that we can quick sort these based on the amount of CPU time each is consuming, the amount of memory each process is consuming, etc. So I'm idle over 90% of the time, so I have a pretty low burdened system at this time. However, utility like Task Manager in Windows or Activity Monitor in Mac OS X can be useful to help you see a process that may be consuming too much CPU. Note that I can right-click the process in Task Manager, come down to Affinity, and in this case I have 4 CPUs or CPU cores to choose from, and I can allow this process to execute only on 1, 2, 3, or 4, depending. Next, let's take a look at random access memory. This is another case where, as we talked about earlier when we formally covered RAM, compatibility is crucial. In fact, I recommended you hit up crucial.com if for no other reason but to learn specifically the type of RAM module that's compatible with your motherboard. So probably the chief issue I've seen in my experience of system lockups that are related to RAM would be if you have the wrong RAM type installed. If your motherboard requires matching pairs, in other words, you do upgrades with 2 sticks at a time and they have to be essentially identical. You can definitely get system lockups with that way. Another common problem is a defective module. We haven't yet talked about electrostatic discharge and the importance of guarding against that when we're working with fine electrical components. But RAM modules are very, very delicate indeed. We want to make sure to handle those modules by their edges and never touch the copper connectivity wires at the bottom of the module. Frankly, the module may be defective from the manufacturer. How do you find out, or how do you test RAM? Recent versions of Windows, like Windows 7, have built-in software RAM tests. Alternatively, OEMs like Dell have RAM tester software built into a separate hidden diagnostic or utility partition, but truly the best way to figure out if you have bad RAM or not is to invest in a hardware RAM tester like you're seeing in this graphic. These can tell you immediately simply by snapping in the memory module as you see here on the top of the unit. It'll run tests and tell you whether the RAM module is valid or not. The downside to these RAM testers is that they're very expensive. So unless you have a dedicated IT department, it may not be worth the cost of purchasing those RAM testers. Some other things to look out for is, again, excess heat. This is chiefly a problem if it's a compatibility issue where you've installed the wrong RAM type on that motherboard. Unfortunately, RAM in most or all cases doesn't have a heat sink or a fan to help that heat issue out. You'll recall when we talked about CPUs almost always will have metal heat sink blades to help distribute the heat, as well as a dedicated fan to help improve that airflow. Finally, RAM-related problems could be software-based as well. Poorly written software may leave or leak RAM once the software is exited. An appropriate or well-written piece of software will load up in memory when you start the application, but when you hit that X button and close it or exit the application should release any RAM that it's instructed the CPU to store for it. If RAM is left behind, that's called a RAM leak, and again, it's the fault of the software, but by blocking out RAM and having it just stuck there on the modules, you can produce system instability and eventually system reboots or lockups because of that. Now let's turn our attention to interface and peripheral device troubleshooting. First, we'll look at the most universal expansion bus interface, and that is the Universal Serial Bus, or USB. Remember earlier in the course we talked about the 2 active versions of USB, 1.1 being old school, very slow, approximately 11 megabits per second, versus the current standard, which is what you always want to prefer on your computers, the USB version 2, that gives us a whopping 480 megabit per second transfer speed. Now, with regard to USB devices, Depending upon the device, you may not even need a driver. Now, I should probably be careful with my words. Any piece of hardware that you install on a PC, whether it be an external plug-in like a USB device or a device that's socketed into your motherboard, is going to need that software boundary between the device, the operating system, and then the user. That's called the driver software. But I found, especially with USB hard drives and USB thumb drives, the built-in driver that Windows provides takes care of that. So it seems as if no driver is required, but of course always a driver is required. On the other hand, you may have USB printers, where again, Windows might be able to give you a basic functionality printer, but you'll always want to make sure to get the latest and greatest driver from the vendor. So if you have a really nifty Canon inkjet printer that you've installed for a user, don't let Windows give you a basic driver. Go to the Canon website and download the latest driver for that hardware. It's going to give you a better experience in terms of accessing more features, and also presumably the more recent driver will be more stable than the previous version. Now, just as important in troubleshooting USB, this is a big issue still, is the safely remove hardware item that we have in Windows. Basically, in Mac, it's not safely remove hardware, you just have to eject the device. In Linux, you would unmount the device. Bottom line is, you never want to take a USB hard drive, an external drive or a thumb drive, and simply yank it out of the plug or the port when you're finished using it. You want to notify the operating system that you want to unplug or eject the device. This is what's called safely removing that hardware. The computer on which I'm recording this nugget is pretty old, really. It's running Windows XP Professional. So it uses this wizard that you see here. You can bring it up, and then the tough part is figuring out which of these drives is the appropriate USB drive. Fortunately, Windows 7 has made it a lot easier to pick out which is which. I happen to have a lot going on my system in terms of external USB hard drives, large capacity drives. I also have thumb drive, and what you're seeing here, IKLM, these are actually flash media drives. I have one of those multi-card readers installed. And the idea here is you select the volume that you want to install and hit stop. Why do we want to do this? Why do we want to safely dismount USB hard drives? Because of what's called disk caching. Remember cache, importance of cache. Whenever you think of cache, think of high-speed access. Similarly, while you have a USB thumb drive plugged in, you may have copied some files, let's say, from your host computer's hard drive onto the USB key. Now, although it appears to you that those files have all successfully transferred to the USB key or vice versa from the USB key to the hard drive, unless you do the safely remove hardware or eject command, you're taking a definite gamble in terms of whether this has actually happened. In order to speed up the system, disk caching means part of the file may have been copied to the USB drive, but not all of it yet. In the background, maybe incrementally, your host operating system is putting bits on the thumb drive, but if you arbitrarily yank the thumb drive, there's a likely possibility that you only have part of the file on the thumb drive vis-a-vis only part of the file on the desktop, and when you try to access the file, it'll be unopenable or damaged. The technical word for a damaged file is a corrupted file. I think I've made my point with that. Next interface, as you'll remember, PS2 is our keyboard or mouse port, definitely old school. Missing ports are one issue. That is to say, you have a newer chassis that has only USB interfaces, and you want to plug in a PS2 keyboard or a PS2 mouse. Is all lost? No. You're simply going to want to find an adapter. There are plenty of adapters that change the plug type from USB to PS2 and vice versa. Remember also when troubleshooting PS2 devices that these are not hot pluggable like USB is. You can unplug your USB mouse, clean it, do whatever you need to do, plug it back in without rebooting the system. 9 times out of 10, that's not going to work with a PS2 device. If you unplug a PS2 mouse, plug it back in, you'll find that you still don't have the mouse until you actually restart the computer. It's very inconvenient. Third and finally, we have the backwards issue. Remember that PS2 ports are generally color-coded and even labeled to make sure you don't plug the keyboard plug in the mouse port and vice versa, the mouse plug and the keyboard port, but it's still possible. If you put them in backwards, you're simply not going to have any keyboard or mouse and the computer will not start. Alternatively, because PS2 is a pin-based interface, if you're jamming and cramming them the wrong way, you could bend pins and permanently disable the device. Finally, you'll recall the FireWire interface. This is the IEEE 1394 standard. We have the 400 Mbps and the 800 Mbps speed. When we're troubleshooting compatibility, we want to match connectors. Make sure before you buy or suggest a customer to buy a FireWire device that they have an appropriate connector on their computer case. You may have to also have them purchase a FireWire expansion card to install on the motherboard of their system to give them some FireWire ports. Alternatively, their computer may have FireWire 400 built into the motherboard, but they want to run an 800. It's not a forward compatible deal. These are incompatible plugs. Drivers, another issue that goes with FireWire devices. You generally have fewer built-in drivers for FireWire than you do, say, for USB, so definitely, if you need to, go to the vendor's website to download appropriate drivers. And then there's the issue of system resources. It used to be several years ago, let's say back in the mid-90s to late 90s, that you had to do a lot of horsing around when you were, say, installing a new expansion card on a motherboard. So for instance, if I needed FireWire connectivity and my computer did not have any FireWire ports, I might buy a ISA or a PCI slot type card to give me some ports. Nowadays, it's literally as easy as powering off the system, snapping in the card, installing the driver, and you're good to go. But it used to be, like I said several years ago, that you actually had to check out hardware resources, for instance, to make sure that your new card doesn't conflict with any other devices that are installed on the system. There was a whole other layer of troubleshooting goodness that was required of the computer repair technician. Fortunately, advances in plug-and-play technology have largely, if not completely, rendered that kind of hardware resource arbitration null and void. Before we move on, let's hit up Google Images again and make sure we're cool on some of the things I described for you. I just ran a search for USB PS2 adapter, and here's where you see one where, for instance, if you have a newer USB mouse, you can plug it into the back of this connector and then plug the mouse into the mouse USB port. So you can go from USB to PS2 and vice versa. The connectors have somewhat different form factors. I also mentioned that FireWire is an example of an interface that can be made present inside a computer chassis by installing an appropriate PCI or PCIe card. Here you see, and this one is going to give you 3 FireWire 400 slots. Something I haven't mentioned but I think is useful is, remember I mentioned RAM testers being really ultra efficient for, well, testing RAM. These are awfully good things to have too if you're doing any significant PC troubleshooting. This is called a power supply tester, and this particular one's very inexpensive. And what you see here is some LEDs that give you diagnostic information on top, and then you see the different form factors for the various power supply connectors, like the SATA power connector, which I'm pointing to here, the traditional Molex connector, and so on. So you can test continuity and strength of your power supply just by plugging it into this device. And then there's digital ones. You can get more jiggy with that if you want to. But there's a lot of these really nice diagnostics. The old school way to do that kind of testing is to use what's called a multimeter that can test for voltage and power and amperage. This one right here is one that I have at my home. You want to be careful with the red or the hot and the black ground leads, and also make sure that you're setting your switch appropriately so you don't shock the system and or yourself. Finally, let's take a look at network troubleshooting. Again, this is a subject that whole books and entire courses are written for, so how can we possibly do this justice in one whiteboard slide? Well, I'm going to give you the basics. Network troubleshooting, you'll recall, takes the form of Ethernet. This is the de facto networking protocol used nowadays. Specifically, Ethernet relies upon transport protocols. In other words, methods for taking data. Ethernet will actually give you the data packet envelope, so to speak, that goes out onto the wire. But then within that Ethernet packet, other protocols get added to it. to provide, for instance, richer and more robust addressing information. I've mentioned a couple times before this TCP/IP protocol suite. With regard to wired Ethernet, some problems or potential points of compatibility problems would be, for instance, one half of the equation, maybe the user's network adapter card is configured for half duplex, whereas the switch port that the user's connected to in the telco closet is configured for full duplex. Now, first of all, what does this mean? Half or full duplex determine data transmission directionality and simultaneity, if that's a word. I may have just coined one there. Cool. I guess I deserve a cookie. Anyway, half duplex network transmissions involves either sending or receiving. It's like a one-lane bridge where only one vehicle can cross at a time in a single direction. As you can imagine, that's going to be quite a bit slower than what we have as our de facto standard for Ethernet, full duplex, where you can actually have sending and receiving signals going simultaneously through the medium. So you're thinking to yourself, my gosh, why would I ever use half duplex? Nowadays, there really is no good reason to use half duplex. Perhaps if you're supporting users who have ancient network adapter cards, you may have to do that. But the bottom line is you want to make sure that the user's network card that's inside their computer, its duplex setting matches that of the switch port to which that user is connected in your server room or your telco closet, wherever you're terminating the other end of that network cable. Now, a really nice feature of switches, and even to an extent your network adapter card software, you have this ability to auto-negotiate. So for instance, if the switch port is set to full duplex, the user comes online with their network interface card. If it's set to auto-negotiate, then it will detect, oh, okay, the switch on the other side of this connection is full, therefore I'm going to go full duplex. Or vice versa, if the client computer is really old and it comes up half duplex, and the switch port is set to auto-negotiate, then the switch will automatically switch down or ratchet down to half duplex for compatibility reasons, you see. Now, where do you get to these options? Any windowed operating system, whether it's Microsoft Windows, Mac OS X, Linux, etc., is going to give you access to your network adapter card properties. So what we're seeing right here is the Windows XP version of my network card properties. You see that my network card is made by Broadcom. It's a NetExtreme Gigabit Ethernet card. And if I click Configure here, it gives me a variety of different options. It tells me specifically where I got my driver, tells me what hardware resources are used. Remember, I mentioned that back in the earlier days of this, you had to arbitrate things like IRQ and memory range yourself. Now you notice I'm not even able to make those changes even if I wanted to. The advanced page is where you can customize, if you really want to, some of these settings that we're talking about now. For instance, you notice that this network card has an advanced property called speed and duplex, and it's set to auto, which is what it should be. But note that for compatibility reasons, we can ratchet it all the way down to 10 megabit per second instead of its default gigabit, 1000 megabit per second. And you note also we can specify half duplex or full duplex. So that's what this exam objective is talking about. I also want to show you this. In a TCP/IP network, the way that my computer identifies itself is by means of something called an Internet Protocol address. You might have heard the term IP address before. Again, entire books, entire courses are written on TCP/IP. You really need to know next to nothing about it for your strata exam, but I guarantee if you do any kind of in-depth work in home or professional computing, you're going to come across it. And no matter what the operating system, no matter what the device, this could be a smartphone, it could be a network printer, it could be a server computer, a workstation computer, a regular desktop. All of these machines either get their IP address automatically from some source, some server source, or you can configure a computer to use a fixed IP address. And IP addresses consist of 4 decimal numbers between 0 and 255. I'm just going to put all ones across here for grins. So you wind up with some number between 0 and 254 actually, dot 0, dot 254, etc. Now there's plenty of rules in what goes into IP addressing that we're not going to get into, but suffice it to say that on a single local area network, each device or each host is going to need a unique IP address. All right, so I'll just leave that at that. I'll set this back to automatic, which is what it was originally, and we'll come back to the whiteboard. The reason I mentioned IP addresses is that no network troubleshooting work is complete without looking into the IP address configuration of that workstation. Drivers are another possibility. Maybe it's not just the driver settings like speed and duplex, but maybe you've installed a buggy driver and that's giving the user fits as far as getting on your LAN, WAN, or internet. Any contemporary operating system is going to give you not only the graphical front end, but also a terminal environment or a command line interface. Here I'm in the Windows command prompt. You can bring up a terminal in Linux or Mac OS X. Heck, even mobile operating systems like Android give you command line access. And the reason I mention this is that there are commands that depend somewhat upon the operating system that you can use to verify and test your TCP/IP network connectivity. In Windows systems, your go-to command is called ipconfig. It stands for Internet Protocol Configuration. And this gives you a run of all of your adapters, your network adapters, their IP address, their subnet mask and gateway, which are related bits of information, and what's called your DNS suffix. And in Windows, you can get more output by typing ipconfig /all. Gives us much more information here, specifically about my Comcast LAN connection. We now see the physical address of my network card. We can see different other server addresses. DHCP server is significant because remember I mentioned if you have your network adapter set to pick up its IP configuration automatically, well, you need some source to receive your IP configuration. That's the purpose of Dynamic Host Configuration Protocol, or DHCP. Now then, a lot of what we're talking about here with wired Ethernet also transfers to our wireless Ethernet as well. However, the implementation is a little bit different. In other words, one compatibility issue would be competing or conflicting wireless protocols. Remember earlier in the course when we talked about the 802.11 standards, we have A, B, G, and N, with A pretty much being completely off the map. A is not compatible with B, G, or N. It's super slow and nobody supports it anymore. The good news with these, though, you'll recall, is that B, G, and N all operate on the same frequency, so therefore they don't step on each other. You can enable 2 or all 3 of these protocol standards on a single wireless local area network, and all things considered, not have to worry about conflicts among your devices. So there's that. That's kind of cool. However, what is a significant barrier to getting wireless working reliably is making sure you have a matchup with security protocols. There's an entire alphabet soup of different choices here. The original security protocol for wireless was called Wired Equivalent Privacy, or WEP. This was kind of a pain in the hinder to set up. You would have this long multi-part string of alphanumeric characters called your key, your WEP key, that you would define both on your wireless access point that associates with your client devices, and you'd need to distribute that key to each client device. The purpose of the key was to encrypt data that was sent from and to those wireless clients. Now, why do you want the data encrypted? That should be obvious. In a business environment, you could be dealing with intellectual property, trade secret, or potentially classified information if you're working with a government agency. The current standard with wireless security protocols is what's called Wi-Fi Protected Access, or WPA. There's different flavors or implementations. WPA Personal is used on many residential or small office, home office WLANs. WPA2 Enterprise is used for, you guessed it, enterprise installations, where you've got the issue, how can I distribute an encryption key to potentially thousands of wireless devices in my network? Well, there's a whole bunch of information there that we don't need to worry about at this point. Just know that the challenge is you need to make sure that if you have a wireless access point set up for WPA with a particular key or passphrase, you're going to need to also ensure that any connected devices are also configured for a WPA environment, and they have a copy of that shared passphrase or that security key. Finally, we have the environmental issue of signal blocking. Remember I mentioned that if you're in the position of planning a WLAN implementation, you want to perform a site survey. And one of the factors that you need to include in your site survey is distribution of signal. In other words, as you plan how many wireless access points you want to distribute through your physical plant, you have to think of things like spread and radius and making sure that the range of those wireless access points doesn't overlap too much with the next nearest wireless access point. That's going to reduce efficiency in your WLAN. But on the other hand, you don't want the wireless access points too far away from each other, because then you create cold spots where a user has a wireless connection where they're standing in, say, a break room, and then they take a step to the right and they don't have connectivity anymore. We want to blanket the entire physical environment with that 802.11 signal. Moreover, we want to consider things like walls, what kind of composition goes into your physical structure, your infrastructure, so that we're allowing, again, signal propagation as much as possible. Reflection is okay, but signal blockage is not. Resolving hardware compatibility issues review. In this nugget, we assessed hardware compatibility on several levels. We started off, I'll add an additional subpoint here, by learning CompTIA's own general strategy for approaching any type of computer technology troubleshooting. Then we opened the case, so to speak, of a PC, and we examined motherboard components like the CPU and RAM, and good troubleshooting points to ponder there. We looked at expansion peripheral interfaces, we looked at USB, PS2, FireWire, and so forth. And then we completed by taking on a very vast subject, but providing what I believe is a very thorough overview to troubleshooting networks, both the 802.3 wired as well as 802.11 wireless. I hope that this has been informative for you, and I'd like to thank you for viewing.